Imagine it's your first day inside a factory. A senior engineer points to a cable and asks, how much current can this 2.5 square millimeter copper wire safely carry? This case. Everyone is waiting for your answer. No calculator, no mobile phone, just your engineering knowledge. Would you know the answer? In this video, you'll learn the practical electrical thumb rules experienced engineers use every day. More importantly, you'll learn when these shortcuts work and when they don't. Before we begin, remember one important thing. These are quick estimation thumb rules. They help electricians and engineers make fast decisions during maintenance, troubleshooting, and interviews. But for final equipment selection, cable sizing, or safety critical design, always perform proper calculations according to applicable standards. Now let's begin with the thumb rule every electrical engineer should know. Imagine you're replacing a damaged wire inside a control panel. Your supervisor asks, can this 2.5 square millimeter copper wire carry a 15 amp load? How can you answer quickly? Here's the thumb rule. For a single copper wire under common installation conditions, multiply the wire size by 6. 1 square millimeter wire can carry about 6 amps. 1.5 square millimeter wire can carry about 9 amps. 2.5 square millimeter wire can carry about 15 amps. 4 square millimeter wire can carry about 24 amps. Simple, isn't it? But here's the important limitation. This is only a quick estimate. The actual current depends on insulation type, installation method, ambient temperature, and cable grouping. Interview question: a 4 square millimeter copper wire is installed in a panel. Approximately how much current can it carry? Answer: around 24 amps under common conditions. Now let's talk about multi-core cables. Unlike a single wire, multi-core cables trap more heat. That means they usually carry less current. A common thumb rule is current approximately equals 4 times cable size. Example: a 2.5 square millimeter multi-core cable carries approximately 10 amps. Why is the value lower? Because heat cannot escape as easily. Higher temperature means lower current carrying capacity. Mini challenge: can a 2.5 square millimeter cable always carry 10 amps? No. Installation conditions can increase or reduce its actual capacity. Let's move to motors. Suppose you're standing beside a 3-phase induction motor. The nameplate says 5 horsepower. Multiply horsepower by 0.75 to get power in kilowatts. More accurately, 1 horsepower equals 0.746 kilowatts. Now let's estimate motor current. For a 230 volt single phase motor, current approximately equals horsepower times 6. So a 2 horsepower motor draws about 12 amps. For a 415 volt 3-phase motor, current approximately equals horsepower times 1.5. A 5 horsepower motor draws approximately 7.5 amps. These values assume typical efficiency and power factor. Actual current varies between operating conditions. Interview question: why doesn't every 5 horsepower motor draw exactly the same current? Because voltage, efficiency, power factor, and motor design all affect current. Imagine a machine repeatedly trips for no obvious reason. One of the first things a maintenance engineer checks is the earthing system. For industrial installations, a single earth pit target is around 5 ohms or less. Large earthing grids are often designed for lower resistance, sometimes around 0.5 ohms. Another check is neutral to earth voltage. Normally, it should be close to 0. A value below 2 volts is generally acceptable. If you measure a higher voltage, investigate further. Possible causes include an overloaded neutral or poor grounding. Interview question: why should neutral to earth voltage remain low? Because a high value may indicate wiring or grounding problems that require investigation. Now let's estimate transformer current. Suppose your transformer is rated at 100 kilovolt amperes. A quick thumb rule is current approximately equals 1.39 times kilovolt amperes. 100 multiplied by 1.39 equals approximately 139 amps. This shortcut works only for a 415 volt volt 3-phase system. If the voltage changes, the multiplier changes. Distribution transformers also draw a no-load current, roughly 2 to 5% of rated current depending on the design. Today you learned 5 practical electrical thumb rules: copper wire and multi-core cable capacity, motor power conversion, earthing checks, and transformer current estimation. Remember, these shortcuts help you make fast field estimates. Subscribe for more lessons. In the next video, we'll explore advanced thumb rules.